Okay, completing the square. Do you remember that? Yeah, it actually becomes an incredibly powerful tool coming up right away. I want to show you something really, really neat. I want to show you probably one of the most important principles out there. It's called the square root principle. Let me tell you what that's all about. It says right here that when you square root a number, the answer could be either positive or negative. What do I mean by that? You've been trained since like grade 5 when you heard a squared plus b squared equals c squared, that whenever you square rooted, you just got bada boom, that number. Case in point, when you square root this number here, look what you traditionally would write down. You would traditionally write down 3. Why? Because you could say, all right, I can check and verify this answer by putting it back into the equation. And you'd go 3 squared, and sure enough, that equals to 9. But I want to show you where the square root principle comes from, because that's interesting. I'm telling you it could be either positive or negative, because look what happens if I tell you that the answer is negative 3. Now, put in the negative 3. Square it. Negative 3 times negative 3, you know this. Negative 3 times a negative gives you an actual positive number. So your answer when you square root can be either positive 3 or in fact can be negative 3 as well. That's the square root principle. The reason why you never said this part before here is because you were always dealing with Pythagorean theorem, a squared plus b squared equals c squared. And when you square rooted, you'd never put down that you had a negative distance, right? I didn't have a negative hypotenuse at any time at all. So you always use positive values. But now you have to know this. Don't forget square root principle, okay? So how would you do it for something like this particular question? Same old, same old. This is multiplication. So first thing you would have to do is divide it out first, canceling this, giving you an x squared equals to 4, and then you would square root this. And you know the square root of 4 is equal to plus or minus 2. And again, if you don't believe me, throw that back into here and just go ahead and even put it on your calculator. But that's the real crux of the whole thing, because when you put it back in the calculator, people forget to put the minus 2 in brackets, and your calculator will turn around and say, oh, that's just a minus 2, and they wouldn't square the minus, giving you a negative number. If you put it in the calculator, make sure you put brackets around it, then square it. Negative 2 squared is 4. 4 times 2, guess what? No thanks, I already. 8, get it? Anyways, so that really helps out. How would you do these questions down here? Virtually the same way. Let me show you. It's really quite neat. Okay, first things first. Again, solve for this. Well, you got the x squared sitting out here, but it's not by its lonesome. Add 4 to both sides. Dun, da, da, da. That's gone, giving you x squared equals to 4. Now square root, x equals to plus or minus 2. Isn't that interesting? Okay, look at this one. Same kind of idea. Add 49 to both sides. See what I mean? Bada boom. That cancels that, leaving you with x minus 1 squared equals to 49. But look at this. This is kind of interesting because you got to do this exponent first before you do what's in the brackets. The way I remember this is, you know, BEDMAS? Here's what I do. When you're solving, you're actually going this direction. Okay? You don't go brackets, exponents, division, multiplication, addition, subtraction. It doesn't work that way. When you're doing algebra, you're actually doing SAM, Deb. Okay? You do the subtraction addition first, like I did here. Right? You do the multiplication division next, if there is any, and exponents and brackets last. Look how the brackets are last. So that's going to help you out with this question right here. Do the brackets last. So do what's inside the brackets very, very last. So you have to square root first, right? Leaving you with x minus 1 equals to square root of 49. It's not 7. It's plus or minus 7. Now this, unfortunately, ends up opening a whole can of worms here. Let me show you the can of worms that it opens. You have 2 questions to solve now. X minus 1 equals to positive 7, and x minus 1 equaling to negative 7. Oh no. Oh yes. Watch this. Add 1 to both sides. x equals to 8. Add 1 to both sides. X equals to -6. So you end up having two answers. Now you're probably saying, well, why would you have two answers? Think about it. Think about it. It's a parabola that has a -6 intercept and a +8 intercept. That's the reason why we have two answers and why we use the square root principle.